Hi, Math 2 students. This is Ms. Van Vickel, and this is part 2 of Friday, April 24th video series on word problems revisited. We are using logarithms to solve for exponents, and we're going to see how that plays out in terms of word problems. So if we look at example 3, part A, the park rangers at a wildlife refuge have been keeping track of the bear population, and there are currently 8 bears in the park. The population is growing at a rate of 4% per year. How long will it be until the population will reach 20 bears? So let's set this up as an exponential equation. We have a starting value of 8 bears, and we know that they are increasing at a rate of 4% per year. So this is what our equation looks like. And then we notice that they are asking us to solve for the time. How long until the population will reach 20 bears? Well, time is right here, and it's in my exponent. So I'm pretty confident I'm going to need to use a logarithm. They did give me the number of bears, though, at the end, so I need to put that in for y. And my equation looks something like this. Now, if you remember from the last video, I want to rewrite this as a logarithm, which will allow me to solve for my exponent. But the difficulty I have right now is I'm multiplying this base by 8, and I need to isolate my base first. So I'm going to divide both sides by 8. That gives me 1. And this simply becomes 20.8. And we could simplify that. I think it makes sense to do that. And when I do, I get 2.5 is equal to 1.04 to the t power. And now in order to solve for t, the way we have been doing it is graphing it in our calculator and looking for the intersection point. But now that we know all about logarithms, we can simply rewrite this as log 1.04 is my base, and I'm taking the log of 2.5. So if we rewrite this as a logarithm, we can solve for t. And now my calculator will evaluate that. I go to the catalog, and I go to log base, and then I tell it, my calculator, that my base is 1.04, and I'm taking the log of 2.5, so that goes here. And if I hit enter, I get 23.36. Let's round that to 23.4. So it will take approximately 23.4 years for my bear population to reach 20 bears if it's growing at a rate of 4% per year. And that's how we use logarithms to solve real-world problems. Let's do one or two more together. I think C and D are probably great examples that we could work together that would help you with your homework. So C says in an experiment, 100,000 cells are decreased by half every minute. How long will it take for the sample to reach 10 cells? Well, we know that we're solving for our exponent because it says how long. So we can say, well, we started with 100,000 cells, and we're being decreased by half. We could write that as 50%, or we could just use a fraction 1/2 there. And so this is our equation, and what they're asking is, what value of t do I need here in order to give me a y value of 10 cells? So again, before I rewrite this as a logarithm, I have to divide both sides by this initial amount of 100,000 cells, not dollars. So I do this division, and I end up getting 10 divided by 100,000, and we can simplify that. as 1 times e to the -4th. And I think it's almost easier just to leave that in fraction form. These divide out to give me 1 though. And so I'm going to simplify a little bit, and I'll go ahead and do that. So I have 1 over 10,000 is equal to 1 minus 0.5 is just 0.5 to the t power. So rewriting this as a logarithm, I would say log base 1/2 of 1 over 10,000 is equal to t. And notice I simply rewrote that as a logarithm. Now I can evaluate this with my calculator. I'm going to say we need to go to log base. And we need to say this is log base of 1/2 or 0.5. And I'm taking the log of 1 divided by 10,000. And when I evaluate that, I get 13.2. Let's round that 13.28 to 13.3. So t is equal to 13.3. What does that mean? In an experiment, 100,000 cells are decreased by half every minute. How long will it take for the sample to reach 10 cells? In 13.3 minutes, I have gotten to a point where I only have 10 cells. So the last one I want to do with you in this series is the half-life. Half-life of iodine-131 is 8 days. How long will it take a 2-gram sample to be reduced to 1/100th of a gram? So again, we've got our equation like this. And what we know is we start out with a 2-gram sample. And since it's half-life, it's being reduced by 1/2. But we need to take the time and divide that by 8. In essence, we want to have to put in 8 days to get a half-life to happen here. And so our exponent looks just a little bit different for half-life because we always have to divide the time by the half-life. And then it says how long will it take a 2-gram sample to be reduced to 1/100th of a gram. So that's this value right over here. How long until this happens? So again, in order to rewrite this as a logarithm, I need to simplify a few things. First, I'm going to divide both sides by 2 because I have to isolate this part that is being taken to a power. So I'm just going to leave this as 1/100th over 2. Those divide out to give me 1. And this really simplifies to 1/2. Excuse me. So our equation looks like this. And what I really would like to solve for is t. So I'm going to write this as a logarithm. Log, my base is 1/2. I get that from here. Of 0.01 divided by 2 is equal to t divided by 8. And I will have solved for t when I multiply both sides by 8. So let's go ahead and evaluate what the log base 1/2 of 0.01 divided by 2 is. Got to get that log base again. And if I get log base out, I'm going to put in 1/2 for the base. And in parentheses, I would put 0.01 divided by 2. And then I would need to multiply that times 8. Why do I need to do that? Well, I've got this 8 right here I need to get rid of. So I multiply both sides by 8 and I get 61.15. So again, what does that mean? How long will it take a 2-gram sample of iodine-131 to be reduced to 1/100th of a gram? And the answer is 61 approximately 15 days. So give your homework a try. Do some of these word problems and use logarithms instead of graphing and finding the intersection in your calculator. And yeah.